So in this chapter, let us begin with the tangent of a curve of this parametric equation. Remember, suppose we are given x is a function of t and y is also a function of t, which is gt in this case. Then the chain rule. So dy over dt, right? The chain rule, it will be dy over dx times dx over dt. Okay, this is a very important properties, and from this we can compute dy over dx, right? By, how can we do so? From this equation, how can we find dy over dx? Yes, that's correct. Perfect. But when we divide by a number, make sure that that number is not 0. Otherwise, the fraction is not defined. Okay? So from this general, we have this relation. The first equation. No, be careful. Dx over dt here, this is the derivative. Is not understood as a fraction. So when you this is one thing, the combination of these. So we cannot multiply with dt over dx. This is different. Okay, be careful. But thank you for your contribution, Aluk. Just be careful about this. It's not a fraction, it's a derivative of x with respect to t, right? It is a function depending on the t variables. Okay, be careful. But anyway, dy over dx, as we know, that is a tangent of the curve y, right, equal to fx. But providing that this denominator is not 0, this condition is very important. If it is 0, it's not defined. Okay. Then this is, we call it the slope, right? We normally see it that way. So let us continue. Here, let us do this example first. The example 1 here, if x is t squared and y is t cubed minus 3t here. Okay. The question A, show that C has two tangents at the point 3, 0, and find their equations. Okay. Before we do this, let us observe this curves. Observation. Look at this. X is t squared. How is it compared to 0? Is it larger or smaller than 0? Any numbers, when we square it, right, is always larger or equal to 0 for any t in R, right? That is the first properties of this curve. What does it mean? It means that if this is the coordinate, then the curves can only be on the right side of this, from x is positive to here, right? Second, y is t cubed minus 3t, okay? If we factor the kind of like term of this guy, what do we have? Very good. T times t squared minus 3. Okay? Look at this. What is the solution of this equation? At what value of t that makes y is equal to 0? What is it? If we set y is equal to 0, then t should be 0, or t squared minus 3 should be 0, right? In other words, it will be t equal to 0, or t is, very good, plus or minus square root of 3, right? So therefore, it means that, okay, let us make a table and study the properties of y. If this table has a row of the value of t here, and t, there's no restriction on t, right? It means that t can take the value from negative infinity to infinity. And we know that y is equal to 0 at these points, at negative square root of 3, at 0, and at square root of 3 here. Okay? For this value, the function t squared minus 3, it is a quadratic function, right? And it will be 0 at the solution here. Do you agree? Therefore, this function is equal to 0 at this point. Okay? Is it clear? And between these solutions, what is the sign of this quadratic function? It has opposite sign of the coefficient in the highest degree here, t squared. Yes, and we see that the coefficient of t squared is the number 1 right here, right? It is a positive number. Therefore, the solution between these will be a negative number. Or it is easy. You can just try to make, very good, Aluk, thank you, and thank you everyone here. Or you can see that you can pick a specific value of t in this intervals. For example, 0 here, right? We substitute here, it will be 0 squared minus 3, which is a negative numbers, right? Therefore, the sign in this intervals will be negative. And outside of these two solutions, it should has a positive sign here. Do you agree? Are we good? If you have any question, just don't hesitate to ask. Okay? Then let us, because the reason we study this, because here we're doing this. We're trying to study y here. So the reason we study this, because here we want to study y. And another function in this product, which is the function, linear function t, right? When t here, what is the solution of this function? 0, right? So, in other words, we know that it will be 0 when t is equal to 0. And on the left side of this, for example, we can pick -1, right? Substitute in this function, it will be a negative number, which means that it will be negative in this intervals and positive in this intervals, right? Okay? And the function y, the y coordinate here is a product of this guy, right? When t is equal to negative square root of 3, y will be 0 here, right? At 0, y will be at square root of 3, 0, okay? Now, how about between these intervals? If t is smaller than negative square root of 3, it would be a product of a positive number times a negative number, right? It means in the end, y will be negative. Very good. And here, negative times negative, positive. Good job. Negative and positive. Great. Okay. Once we study these two things, x and y, we know that, okay, the curve should be on the right side of the OY here, right? And when t is from the intervals y will be negative for t in the intervals from negative infinity to negative square root of 3 and for t is between 0 and square root of 3 here, right? So it below the y, the x-axis. Okay, let us add one more page here. And another case, y will be positive. Let us say strictly positive. For t is from negative square root of 3 and 0 here, or from this interval, from square root of 3 to infinity. Okay, that's it. This is the properties of the curves, okay? Then let us do the first question. They ask us, okay, show that C has two tangents at the point 3, 0, and find the equations. The question A. At the point 3, 0, right? It means x, which is t squared, y, which is t squared, or let us write it in the cube form here. Write it this way. Anyway, from this point, it gives us the equation here. X will be 3 and y will be 0, right? At this point. So our job is to find the value of t corresponding to this point, right? So from this, t squared is equal to 3. What does it mean? Yes, t will be plus or minus square root of 3. Okay? And here t will be 0 or t will be plus or minus square root of 3. And remember, in mathematics, and we write it this way, and or we write it in this notation. Okay, that's it. Or and finally we have that. So when at this point corresponding to the value when t is equal to negative square root of 3 and t is square root of 3. The curve of these parametric equation pass the points 3, 0. Okay? Are we good? Is it clear or is it okay to all of you? So there are two values of t. Now the curves pass this point. Okay? So then we need to find the equation of the tangent. Okay? The tangent, oh, we need to find the two tangent at this point. This is the value of t only. We haven't found the tangent yet. Remember the tangent dy over dx from the above equation, the formula, it will be dy over dt over what? Thank you. Okay. Thank you, Jacob. So what is dy over dt? Yes. Y is this, right? Dy over dt will be 3t squared minus 3. Good job. And x is t squared. So what is dx over dt? Yes, 2t. Can we simplify it? Thank you, Luke. Or okay, this is the tangent for any point, right? So this means it is also true. Therefore, it is true for the tangent at this point, right? And this point. It will be dy over dx when t is equal to square root of 3, right? It will be this guy. What is it? When t is square root negative square root of 3 here, right? Substitute the value into what we found here. Okay? And it will be yeah, just substitute here. And then we simplify it. Okay? Now do it yourself and let me know the final result. Okay, it will be 3 times 3 here, right? Minus 3 divided by negative 2 square root of 3, right? It will be 6 divided by negative 2 square root of 3, right? And therefore, it will be 6 6 is 3 times 2, right? If we write it this way, it's easier to see. 2 we cancel with 2. The negative sign is still here. And 3 will cancel with square root of 3, give us, okay? It means that at this point, when t is negative square root of 3, the tangent will be negative square root of 3. Is that okay?
Why does the 3 go away?
Okay. So it will be 2 times 3 right here, right? And it is negative 2 square root of 3. And 3, instead of writing 3 here, we can write it square root of 3 times square root of 3 here. Okay? Then this guy cancel with this guy. This guy cancel with this guy. Okay? It becomes negative square root of 3. The same story. Okay? Okay, thank you, Luke. So when t is equal to square root of 3, then we know that the tangent will be yes, square root of 3. We do some algebra and it will be square root of 3. Okay? Are we good? Perfect. So the tangent, okay, let us draw the coordinate here and see. If this is 1, this is 2, this is 3 here, right? The tangent at this point, 3, 0, it has 2 tangent. One is square root of 3, which is 1.7 something. It should be like this. Oops. Right, this is tangent at this point, square root of 3 here. Okay, and negative square root of 3, therefore it should be like this. So far we know that much, okay? And the equation of this, remember, the tangent line, it should be a linear function, right? A linear function has a forms y is equal to ax, or let us write it mx plus b, right? Where m is the tangent and b is a constant. And when this tangent line passes through the point 3, 0 right here, it means that this point should satisfy this tangent line, right? Therefore, the tangent via this point, the tangent line, pass through the point 3, 0 with the slope m is square root of 3 is y is equal to square root of 3 x plus b here, right? The point 3, 0 belong to this line. Let us call it the line D. This point 3, 0 belong to the line D here. This implies that this equation, these points should satisfy this equation, which means 3 equal to square root of 3, 0 plus b here, right? When we substitute the value of x and y here to this equation, it should satisfy. Okay? From this, what is the value of b? Wait. Y is 0, right? Sorry, my bad. Y is 0 and x is 3 here, right? My bad. Okay, good job. It means that b will be great, right? Therefore, the tangent line satisfying that, it will be y is equal to square root of 3 x minus 3 square root of 3. Or we can write it in a better way. Y is, let us factor negative square root of 3 out. It will be x minus 3, right? Okay. Are we good? Good job. Similarly, so the tangent line pass through the point 3, 0 with the tangent m is negative square root of 3 is, so you can double check it, but let us just write it down. And we do the similar things. We will find the line L, y will be negative square root of 3 and x minus 3. Double check it yourself, okay? Just solve the question A, okay? Do you have any question up to this point? Okay, just move on. Find the position, find the point C on the curve C, where the tangent is horizontal or vertical. Here, let us look back the notes here. Look at this. dy over dx is dy over dt over dx over dt. The horizontal tangent, it means that the line should be like this, right? Or in other words, the slope of that is 0, right? And the slope is given by this equation. It means that dy over dt should be 0, okay? That is one condition. But the denominator here should not be 0. Otherwise, it is undefined. So that is why we have this condition. Dx over dt is not 0. Okay? Another property is it has a vertical tangent. It means that the tangent line should be like this. It's vertical. Or the slope will go to infinity. in which case dx over dt should be 0 and dy over dt should be a constant, right? These are two cases. But remember, in sketching this, the second derivative will tell us if the curve is concave up or concave down, right? It is in Cap 1. So it means that we need to compute the second derivative of y with respect to x. But be careful. Again, we use chain rule. Suppose we know dy over dx. We want to find dy squared over dx squared, or d over dx of dy over dx, right? We want to find this guy. And dy over dx is a function, right? Depending on t, or in other words, we need to find d over dt here of this guy. And the chain rule here, same story. D over dx of this guy times dx over dt. This is the chain rule. From this relation, we can find this guy, right? By dividing both sides by dx over dt. That is why we have this equation, okay? So remember, this is d over dt of dy over dx. And the denominator again, dx over dt. Just be careful. Okay, so in order to answer the question B here, the tangent is horizontal. It means that dy over dt should be 0, and this one, right? Dx over dt is not 0. So in the question B here, the condition is that it means that dy over dt should be 0 and dx over dt is not 0. Okay? So our job is to find dy over dt, which is 0. We have done that at the very beginning. This implied t will be 0, or t is plus or minus square root of 3, right? Okay. Then the second condition we need to check is to check if dx over dt at this point, if these are 0 or not. Should not be 0. So at t is equal to 0, dx over dt, we remember that it will be t 2t, right? It is 0, okay? So dx over dt in this case is equal to 0, therefore it does not satisfy the horizontal tangent condition here, right? And we need to check these two values of t, right? At t is equal to negative square root of 3, dx over dt of t is equal to negative square root of 3 will be, what is it? Yes, my 2 times negative square root of 3 which is negative, or it is not 0, right? So we conclude that this curve has a horizontal tangent at this point when t is equal to negative square root of 3. Okay? Because dx over dt at this point is not 0, and dy over dt at this point is 0. That is the first point. Okay? The second point, the third point, at t is square root of 3, dx over dt of this point will be, yes, 2 square root of 3, which is not 0. Therefore, the curves has horizontal tangent. At 2 points. Where t is negative square root of 3 or t is square root of 3, right? At t is negative square root of 3, x will be t squared, or what is it? 3, right? And y will be, wait, there's a mistake somewhere. Let me see. At dy over dt, no, dy over dt is not this point, this bad. We skip a step and we got a mistake here. Y is t cubed minus 3t, right? That is bad. So therefore, dy over dt should be this is my bad. Okay, we solve this guy. Therefore, t will be -1 or +1, right? Sorry, it was a mistake. We do it too fast, and yeah. So is that okay right now? So we found only two values of t at -1 and 1. So the same things we check if dx over dt is not 0 at this point, and it is clear that they are not 0 at this point, right? So therefore, the curves had horizontal tangent at this point, plus or minus 1. Okay. Then, in this case, when t is -1, then x will be, what is it? Very good. And y will be 2, right? And when t is 1, then x will be 1, and y will be -2, right? That is the first question of the part B, and let us find the vertical tangent, right? The tangent where it is vertical. This is a long problem, right? But when we master these problems, it will be easier. So the vertical tangent, it means that dx over dt should be 0 and dy over dt is a constant. It should not be 0. Yeah. And again, dx over dt is d over dt of t squared or 2t, right? So the condition is dx over dt should be 0. Imply that t will be 0, right? At t is equal to 0, what is dy over dt? Which is -3, right? Therefore, the points here, it will be x is, yeah, so it is true. This dy over dt is not 0. And let us consider t is equal to 0 here, right? What is x and y? 0 and y will be 0, yes. Very good. Okay, so we found these points, okay? Let us do it quickly. The question C, determine where the curve is concave up or concave down, right? It means we need to in order to answer this question, we need to find the second derivative of this guy, right? Or from the previous formula, we need to find d over dt of dy over dt divided by dx over dt. Okay? What is dy over dt? This guy, right? And dx over dt is 2t, okay? Now, from this point, we take derivative with respect to t one more times. What do we have? Wait. No, dx over dt. This is a wrong formula. This is this should be dy over dx. My bad. We memorized a wrong things. And dy over dx, we just found it above here. Dy over dx. Here, right? Dy over dx is this guy. Okay, yeah, this is wrong. So it's not difficult. It is a quotient, derivative of a quotient, right? I'll do it here. I'll just write the result and you will double check it. 3t squared plus 1 over 4t cubed. Tomorrow we will continue with this, okay? But your job is just go home, review this, do it yourself, and yeah, look at the notes I gave you. Have a good one. For those who haven't got the test one, just come here.